Hey everyone, and welcome back for another deep dive. Today, we're going to be looking at something that sounds pretty sci-fi, quantum computing and what it means for the future of cybersecurity.
Yeah, it really does seem like sci-fi, but it's a lot closer than you might think.
Yeah, and it could have some big impacts.
Definitely. And this is something that everybody needs to be thinking about, whether you're worried about keeping your data safe or national security, it's a big deal.
Okay, so let's just jump into it. What exactly is quantum computing? How is it different from the computers we're all using right now?
Well, at its core, quantum computing is really all about using these principles of quantum mechanics to do calculations in a way that classical computers just can't. Classical computers use bits, which can be a 0 or a 1.
Right.
But quantum computers, they use these things called qubits.
Okay.
And qubits can be in a superposition, which means they can be both 0 and 1 at the same time.
Wait, hold on. They can be both 0 and 1 at the same time? That's wild. How does that even work?
It's kind of like if you flip a coin, before it lands, it's both heads and tails, right?
Yeah.
It's a similar concept. So these qubits, being in multiple states at the same time, let quantum computers do some calculations way faster than classical computers, like exponentially faster.
So they're not just faster, they're kind of doing things in a totally different way.
Exactly, yeah.
Okay, I see that. But how does that tie into cybersecurity? How does that come into play?
So a lot of the ways we encrypt things today, the math behind it, it relies on the fact that it's really, really hard for computers to factor large numbers. I mean, it would take them years, maybe even centuries, to break some of the codes protecting our data today.
Right.
But a quantum computer, a strong enough quantum computer, could do it in a fraction of the time.
So does that mean that, all of our data is vulnerable, our digital fortresses, could they just, crumble with this new type of attack?
Well, there's this one algorithm in particular that people are worried about, and it's called Shor's algorithm.
Okay.
And Shor's algorithm, if you run it on a powerful quantum computer, it could actually break a lot of the public key systems that we use today, like RSA, which is used to secure a lot of our online transactions.
Okay, so is Shor's algorithm like a quantum skeleton key? Could it unlock all of our digital secrets?
Yeah, that's actually a really good analogy. What makes Shor's algorithm so powerful is it can use superposition to do a lot of calculations at the same time. It can basically check every possible solution at the same time, and that makes it really, really good at factoring large numbers.
So I'm starting to get why this is a really big deal, but I guess my question is, just how close are we to having quantum computers that can do this? I mean, is this something we need to be worried about right now, or is this way off in the future?
I mean, there's a lot of research and development going on right now, and people are making a lot of progress really quickly. Actually, there's a startup called Quantum, and they're trying to get a commercially viable quantum computer ready by 2027.
2027, that's not that far away.
Yeah.
So are we all doomed? Should we all just ditch our computers and go back to pen and paper?
Well, not necessarily. Even though quantum computers are getting better and faster, experts think we still have some time, maybe a decade or so, before they can really threaten encryption methods that are widely used today, right? So we have some breathing room.
Okay, that's good. That's good.
Yeah, it gives us time to adapt.
So if, all of our current encryption is going to be useless, I mean, what's the plan? What are we doing?
Well, researchers are working on this gun called post-quantum cryptography, or some people call it quantum-safe encryption. And it's basically just new types of encryption algorithms that are, made to be resistant to attacks from quantum computers and classical computers.
Okay, so we're not just going to be sitting ducks waiting for the quantum apocalypse, right?
Exactly.
Okay, good, good. But, how do these quantum-safe algorithms actually work? What makes them different from what we're using now?
Well, they're built on different math problems, ones that quantum computers, at least we think quantum computers, will have a lot of trouble solving. One approach that seems promising is called lattice-based cryptography.
Lattice-based. That sounds interesting, but I have no idea what a lattice is in this context.
So picture a grid of points in space.
Okay, yeah.
That's like a really simple lattice. But for lattice-based cryptography, we're talking about lattices with way more dimensions, like hundreds or even thousands of dimensions.
Whoa.
And the security of these systems comes from how difficult it is to find the shortest vector within that lattice.
Shortest vector.
Yeah, so imagine you're trying to find, the shortest path through this super dense and complex forest.
Okay.
There are so many paths, but there's only one that's the absolute shortest, right?
Right.
So for a regular computer, finding that shortest path in a really high-dimensional lattice, it'd be like trying to go through that forest blindfolder. And even for quantum computers, with all their power, it's still a really, really hard problem.
Okay, so we're building our defenses on a mountain range instead of a flat plain.
Exactly.
Yeah.
Much harder to attack.
I get it.
That's what makes lattice-based cryptography so cool.
So lattice-based cryptography, that's just one way to do it, right? There are other ways to make quantum-safe encryption.
Yeah, for sure. There are a few others. There's code-based cryptography, and that one uses error-correcting codes to make it hard to break. And then there's hash-based cryptography, and that relies on the properties of cryptographic hash functions.
Wow, so we're not putting all our eggs in one basket.
Nope.
There are a lot of different options. So are any of these, like, ready to use? I mean, are they actually being implemented, or is this all just theoretical?
Some of them are actually being tested and used right now. Like, for example, Google, they tested out a lattice-based system in their Chrome browser.
Oh, wow. So this is really happening. So, okay, quantum computers, yeah, they're a threat, but it sounds like we're not totally unprepared. There are people working on solutions, and they're making progress.
Yeah, that's right. And cybersecurity is always changing, and, quantum computing is really just the newest challenge.
Right, right.
But throughout history, every time there's a new challenge, we've always found a way to deal with it, right?
Absolutely. So it's kind of like a constant arms race between the people protecting information and the people trying to get it.
Yeah, I guess you could say that. And now that we're moving into this new era of quantum computing, the stakes are just getting higher. But I think we can definitely create some strong quantum-safe solutions and keep our data secure in the years to come.
So this has all been super fascinating, but I got to say, it's also kind of a lot to take in, Like, how do we even begin to think about what this all means for the average person?
I think that's a great question, and it's something we should talk about in the next part of our deep dive. We can talk about the impact on society, the ethical stuff, and what people and organizations can do to get ready for this quantum future.
Welcome back to our deep dive on quantum computing and cybersecurity. We've talked about a lot, like the basics of quantum computers and how to make encryption that quantum computers can't break. But what about, like, the bigger picture? How will this affect society?
Yeah, that's a great point. Quantum computing isn't just a technology thing, it's a societal thing, and it'll affect everything from the jobs we have to how we think about security and privacy online.
Okay, so let's start with the good stuff. I know we've touched on this a bit, but, like, what are some positive changes quantum computing could bring?
Well, think about this. What if we could make new drugs and therapies super fast because we had quantum simulations that could, figure out how complicated molecules work?
Yeah.
Or how about materials science? Quantum computers could help us make completely new materials with, like, crazy properties that we haven't even thought of yet.
So it's not just about faster computers, it's about doing things we can't even do now.
Exactly. And it goes way beyond just medicine and materials. Quantum computing could totally change things like artificial intelligence. We could have AI that's way more powerful and, smarter than anything we have now.
So quantum computing could be a game changer for a lot of fields. But we have to talk about the downsides too, right? What are some challenges or risks that we need to be thinking about?
One of the biggest worries is that people could lose their jobs. As quantum computers get more powerful, they might be able to do a lot of the jobs that people do now, and that could really change things for our economy and society.
That's a good point. Like with any big technological change, some people will benefit and some people will be left behind. So what can we do to make sure everyone benefits from quantum computing?
Education and retraining are going to be huge. We have to help people learn the skills they'll need to succeed in a world with quantum computers. And we need to start thinking about this now, not 10 years from now when it's already happening.
So we have to prepare society for these changes, not just focus on building the technology itself.
Right. And there are ethical questions too, like who gets to use this powerful technology? How do we make sure it's used for good and not for bad things? These are questions we have to ask ourselves now.
It's a lot to think about, but it seems like this is something everyone needs to be talking about. So as we finish up, what are some key takeaways you want listeners to remember?
Okay, so first, quantum computing is coming, and it's going to change our lives in a lot of ways, both good and bad. Second, we need to prepare now, not just with the technology, but also as a society.
And third, it's important to stay informed and involved. This isn't just for scientists and engineers. This is something that affects everyone.
Absolutely. The future of quantum computing isn't set in stone. The choices we make now will determine how it all plays out. So let's make smart choices, talk about these things, and work together to create a quantum future that benefits all of us.
That's a great point. Thanks for joining us on this deep dive into quantum computing and cybersecurity. It's been amazing and honestly a little bit scary too.
It has been a wild ride, but even though there's a lot we don't know, it's also exciting. We're at the beginning of a new era of technology, and that always brings amazing opportunities.
So let's be open to new possibilities, stay curious, and face this quantum future together. Thanks for listening. CEY.